very much, and we're glad to be part of the day. We know that this conference opens up a lot of doors for people, like you said. So I suppose we should get started. As you just heard, our session is called Enough of the Azure Pipeline GUI Demos for Data Platform Deployments. And you will see why it's got such a nice long title shortly. But basically, it's a session devoted to YAML-based pipeline demos in Azure DevOps.
So for the next 60 minutes or so, we'll give you a brief overview of Azure DevOps, followed by a short history lesson about Azure pipelines and how YAML came to be. We will then quickly cover the agents which we need for our pipelines to work. And after that, we will jump straight into various scenarios for Azure DevOps deployments, introducing you to concepts in Azure DevOps along the way.
Yeah, and just to set some realistic expectations about this session for the start for everybody. So first of all the deployment pipeline demos that you see today are YAML based, which means there will be no GUI pipeline demos being done in Azure DevOps. So I do know that a lot of the demos you see are GUI based and have been done with the classic editor. However, things have moved forwards a bit, as you will find out shortly with the nice history lesson we're going to get. And also, all of the database demos that you see today are using state-based migration, purely because the fact we cover a lot of YAML in this session. So to add 2 different migration strategies into it as well would probably be maybe a bit too much. And we are also very aware that you will probably see a migration-based session during this conference as well. So our recommendation, I should say, is get the most out of this session for the YAML. And if you are looking to use migration-based deployments instead, well, just take the knowledge you learn over for the migration-based deployments with the YAML we show you today. Anyway, now we've gone through those expectations. Sander, shall we introduce ourselves?
Yes, shall we? So I am Sander. I am a SQL Server DBA from the Netherlands. I'm a Cloud and Data Center MVP, and I'm a major contributor to the DBA Tools project. I have about 20 years of experience in IT and over 15 with SQL Server. You can follow me on Twitter. I have a blog, and if you have any questions after this session, feel free to send me an email. The demos about the SSDT part you'll see today will be available on my GitHub page. Just go to my GitHub page and then to the presentations repository, and you will find this session and the demos right there. They're free for you to use, change, or reteach. They're yours. Just do whatever you want to do with them. And now back to Kevin, who has a slightly more complicated bio than me. So go ahead, Kevin.
Well, thank you very much for that, Sander. And yeah, on that note, my name is Kevin Chant. I'm a lead BI and analytics architect living in the Netherlands. However, as some of you might be able to pick up from the accent, I'm originally from the southwest of the UK. However, I live in the Netherlands due to the fact my wife is Dutch. So basically, I'm an Englishman living in the Netherlands, working for a French-based company because he met a woman in Australia. Now, whenever I say this out loud, I realize why Sander thinks this is complicated. Now, I've worked in IT since the days of Windows 95, and I think that's as much as I should say about that. And over that time, I've had experience in various sectors, including the banking, oil, and health insurance industries. And along my years of working in IT, I've gained various certifications, including both the old and the new style MCSE. And more recently, well, I say recently, it was last year now, I became a Microsoft certified DevOps engineer expert, which is fairly relevant for this session. And as you can see, I'm also a Microsoft Data Platform MVP. Now, just like Sander, you can find me in a couple of places on social media like Twitter and LinkedIn. I have my own blog where I do blog a lot about using Azure DevOps and GitHub for data platform deployments. And I have my own GitHub as well. And there will be some templates which are similar to some of the demos you see today available on my GitHub later on today to coincide with this month's T-SQL Tuesday. So, quick question is, what is Azure DevOps? And in short, it's a collection of services that you can use for your application lifecycle management. So, if I go over to Azure DevOps now and straight to the top, we will just give you a quick overview for those of you who are not overly aware of everything inside Azure DevOps. It won't take too long. So Azure DevOps has its own hierarchy. So here's an organization, as you can see here. You have access to various organizations on the left-hand side. If you have the right permissions, you can change various settings at the organization level. This includes settings for pipelines. I'm not going to go into all these settings. We may cover some of the more important ones during the course of this session. However, just be aware that they affect the entire organization. Now, each organization can have one or more projects, which comes with a default set of services, as you can see here on the left-hand side. And again, if you have the right permissions, you can change various settings at the project level. In the real world, this is where more people actually have enough permissions to do things. And again, there's a whole set of pipeline-related permissions here. And again, we may cover some of these during the course of this session, but we're not going to dive into them too much. But you might want to pay attention to Azure. We will pay some attention now to agent pools, because we use agents a bit, as Sander has already mentioned. So you can manage your agents pools at the project level here. And if I click on one, you can dive even deeper. You can see what agents you have. You can dive into the details of the agents, get some analytics, etc. You have some other settings as well, and retention settings to do with your test management. Service connections is one that we will be covering in this session as well. Basically, you can create connections to external resources. In the case of today's session, this will be Azure resources. However, if I click on new service connection, you can see there are other resources there. However, I'm not going to dive too much into all of the different project settings. That's not what we're here for. So let's move on to the next slide to see how those default services that we just saw all work. So you have work items, as you may have seen on the left-hand side just now. If we go back there, these are work items. Azure boards, which you use to manage your work items. Then you have Azure repos, which we will be using a lot today. Not to show you that much, but all of the demos have all of its repository or data, so to speak, or code stored in these repositories in Azure repos. For the benefit of those who haven't seen Azure repos before, it's basically a GUI visualization of a Git repository. You can think of each of these repositories as, for example, conceptually a bit like a folder share. So it contains lots of files with all different types of code in it for you to use. And when we work with YAML pipelines, those pipelines are actually stored as code, as you can see here inside the repositories as well. And Sander will talk more about why shortly. And then next, we have Azure pipelines, which is where we will be covering a lot of this today. This is where all of our CI/CD work will be taking place and where all the YAML files will be working in. There's also Azure Artifacts, which is another service in Azure DevOps, which allows you to store packages. For those who have a Linux background, you can think of the feeds that are used in Azure Artifacts a bit like Linux repositories. And then you can do manual tests in Azure DevOps using Azure test plans. And I think that's the fastest I've ever done this introduction to order services in Azure DevOps. Anyway, so as you can see, and right in the middle of the screen here, we will be focusing on Azure pipelines today.
So now I'll give you a brief, a quick history lesson about Azure pipelines. Azure DevOps used to be known as VSTS or Visual Studio Team Services. It was later rebranded to Azure DevOps, and with that came Azure Pipelines, which had two main features to handle CI/CD deployments. Those were called build and release, and they were both GUI based. However, Microsoft, thank God that they did that, decided to start using YAML for CI/CD deployments, which meant for both build and releases, they could all be done in one feature. And with this in mind, Microsoft replaced all builds with the feature called pipelines. So now you can still use the GUI versions. In pipelines, you do this by selecting the classic editor instead of the YAML pipelines, and the release feature still exists as well. However, YAML is the way forwards, which is why we are doing this session.
Yeah, so just to help you visualize what Sandra just said, this was now known as pipelines. There was actually another feature here before called builds, and then you would use releases with it, and they were separate. So you'd have to do your builds in one feature. So for in terms of SQL Server to build a DAP for deployment in the build section, and then to do the releases to different SQL Server databases, you would use another feature. However, with YAML, you do it all in one now in a feature called pipelines. And I will show you quickly where you can do the classic editor. But yeah, YAML is the way forwards, to be honest with you. If you do have existing GUI builds, then it's worth looking to convert them to YAML.
So there are two types of agents that we can use with Azure pipelines. These are the servers that are used to process all the work in the deployment pipelines. Something like creating SQL Server artifacts and deploying them. For the Azure services, you'd normally use something called Microsoft hosted agents and self-hosted agents for services you connect locally, which you will see us do later on in this session. For performance reasons, we've decided to use the self-hosted agents for most of the demos today. In fact, Kevin can show you the running application on this laptop now.
I can indeed. And it looks like we've had a timeout and reconnect as well. Basically, as you can see here, I'm running Azure DevOps agent from the command line in PowerShell. And the reason that I've decided to do that is because I test a lot of Azure DevOps agents and GitHub Action runners locally on my laptop. So if I install every single one as a service, my service command would be very full. So if you're think you might be doing the same, the good thing to do is to just install your agents in the separate folders and just run them when you need them. So I'm guessing now that we've done the basics, we should dive into the YAML demos. And we'll start the SQL Server ones first. So, however, before I get started and we do the initial first one to show how to do a deployment, and I'll give you a teaser of what is coming. A lot of these pipelines are based on one Azure DevOps repository, which can be created using a tool which Sander has written. So he is going to first demonstrate how you can actually use this tool yourself to create your own entire solution to be used within Azure DevOps. So over to you, Sander.
Yes, so I am going to share my screen. If I'm right, you can see my Visual Studio code right now, right?
Yeah.
Okay, cool. So when I first started doing anything with databases in source control, my current employer had about 40 to 50 databases. And making solutions for that was really tedious. So what I did was I made one solution how I perfectly wanted it to be, and I created a template out of that using the PS module development PowerShell module. This is part of the PS framework, which is really can just be installed from the PowerShell gallery. And by that, I created a template called the SSDT with T-SQL-T template. And this is a lot of code, but most of the stuff it does is downloading and extracting and installing the template. The most important part is the invoke PSMD template. So let me run that. And now it's going to download the latest version of my template from my GitHub repository. And now I have my solution. It literally took seconds. So let me open that in Visual Studio. And there are two projects within my solution. One is for the data model, and the unit testing is the name of my database. And then there is the unit testing tests, which would contain my unit tests for my database. The solution also contains a build folder, which contains a generated pipeline for Azure DevOps and a workflow for GitHub Actions. And this will help you get started right away, because if you use this pipeline, you can just import it and you will have tests for both SQL Server 2017 and 2019 straight away. So you don't have to create the entire pipeline yourself. And we kind of use it in our demos, but this will help you get started really quickly. So that is the tool that I've written for that. It's freely available, and as you can see, it's in my demo, so you can try it out. Back to you, Kevin.
Thank you very much. And let's see if I need to take the screen back. Indeed, this is some seamless migration, yeah. So just to show you what Sander is talking about, and just so you can see how it looks itself in Azure DevOps. If I can find the right one, here you go. I actually put DPS at the front. So this is how Sander's project looks, a solution that he created looks when it's uploaded into Azure repos. We've renamed some of the folders and files today just to help with getting to grips with what they actually do for everybody. Of course, a lot of the functionality you will figure out further along the lines. So anyway, enough of GUI screen. Let's go and look at some code. So as it says on the screen, first of all, we're going to test deploying to a local SQL instance. Now, I have multiple SQL instances running on my laptop at the moment, and they are actually running as Docker containers. And that's what we'll be mostly using to test the local deployments today. Now, back over to the YAML, because that is what everybody wants to look at. Right, now, I am just going to press, because I don't know how the visibility is for everybody. I'm just going to make sure the screen is more visible for you all as we scroll down here. So for those of you who have not seen a CI/CD pipeline in Azure DevOps based on YAML before, here's a light introduction for you. So at the top of the YAML file, these are all comments. So if you use the #, which some people call a hashtag as well, at the first line in the YAML, then it will be a comment. And as you can see here, first of all, we've got some variables which will apply to the entire pipeline. Here we've got a trigger in place, and you will see here I've got an exclude for the main branch. Now, usually if you're doing continuous integration and continuous delivery, you would have an include for a branch. However, we have quite a few pipelines today, all based on the same repository. So if we set them all to include, every time we made a change, all of the pipelines would try to run at the same time. However, we will shortly be showing you continuous integration in action with a different pipeline. So you can actually see it working as well. So if I scroll down, set a trigger. This particular trigger is set for an update to a branch, which means if you've updated a file in a branch in your Git repository. However, these triggers can be other things as well. For example, you can actually have a schedule set so that you can, using what's called cron syntax, which may be familiar to those with a Linux background. So for example, if you have a database that's used for integration tests and you only want to update it in the evenings, you can set a schedule for it to have database deployments done in the evening so that all the tests can be done out of hours. So as you see, if we scroll down, we specify a pool. For this particular demonstration, it makes sense to use what Sander said earlier, a self-hosted agent, which is in an agent pool. So basically, if you want to use a self-hosted agent, it has to be in an agent pool, as we saw earlier in the project settings. So we need a self-hosted one because it's a local SQL instance. So if you have SQL Server instances on premises, for example, then it makes sense to use a self-hosted agent to be able to connect to those. Because sometimes if you use a Microsoft hosted agent, you can have issues, for example, with firewall requests, etc. So in Azure DevOps, you can use these things called stages. And what I'm going to do is just run this pipeline and then come back to the YAML a minute. Because if I click on the run here, I'll be able to quickly show you why we. So you have a nice diagram here in a pipeline that's running, and that's because of the stages syntax that we're using today. And we've taken it upon ourselves to use the stages syntax right from the start so that to get you used to the idea of logically separating your deployments so that you can actually see them as well. And it's easier to troubleshoot this way. In reality, you can not have the stages and just use directly jobs. Now, there are the standard jobs that you can use in the YAML schema for Azure DevOps, and there is something called deployment jobs as well, which we'll cover shortly. Each have their own pros and cons. With this, obviously using just the standard jobs, it's quite useful if you're just doing something for testing purposes. So when you specify a job, you say what it's called, and then you give it a display name as well. So as you can see, we can use this display name value to give things a nice user-friendly name. And each job can have one or more steps. And well, each job has various steps, and these steps can contain one or more tasks. And these tasks you can think of, if you're using PowerShell, you can think of them on the lines of PowerShell modules, so to speak. And if I click on Show Assistant, which I actually removed earlier, you can see that you can actually quickly find different tasks on the right-hand side here. And in fact, when you click on one of these, so for example, if I click on SQL, and if I click on one of these, you'll see that you get a user-friendly interface appear if you're doing it inside Azure DevOps. Now, in reality, for various types of deployments, you would use something like Visual Studio Code, and you would change the YAML in there if you're very used to working with it. But obviously, whilst you're finding your feet, so to speak, you might want to do it directly in the interface in Azure DevOps. So you fill this out, and then you click on Add, and then it will appear in your YAML all completed for you. However, just be aware that you need your cursor to be in a sensible place when you do this. Otherwise, it might end up appearing in the middle of one of your tasks. So for this particular pipeline, we go and build the database project that's in the repository, which we showed you just now. And that will create a DAT pack, and then we're just publishing that artifact into Azure DevOps. And once that's done, we have a separate stage called release. And that release stage then goes off, sets a couple of variables just for location purposes. We then download the artifact because if you have separate stages and you use agent pool with multiple agents, it could end up on a different server. So you download the artifact and then you can install the artifact on the SQL Server instance that you want it to go to. And for this particular example, you can see we've used variables for this. And there are some alternatives which we'll be showing you during this session as well. So if I go back here now to the top and click on here, you can see that the deployment is completed and it's deployed to an Azure SQL database. And in fact, if I click on one of these, you can see that all those display name values we entered are on the left-hand side here. So you can easily check the progress and look for if there's things you want to investigate further. And here at the results screen, you can see an artifact is published. And if you click on there, you can see there's a SQL data pack. So that is your first one. So our next demo is for an Azure SQL database. Now, this one is very similar, to be honest with you. So again, we're just saying variables. You can set the trigger. Notice this time though, I've got an include. And there is a reason why we've got an include on this particular one, because we want to show you how you'll probably do continuous integration in the real world. You won't always directly edit the repository in the pipeline in Azure DevOps. Like I said, you'll probably use applications on your machine at this moment in time. So if we go into Azure Data Studio, you can see I actually have made a local copy of the database project that Sandro created, as you can see. Well, not that Sandro created, but the database project in the repository. So essentially, this is the same as an Azure SQL database repository that we actually have in Azure DevOps. So if I just open files here, I can actually show you the repository. As you can see, exactly the same. It's a local, what we call in terms of get a local claim. You can think of it as a local copy if you're fairly new to Git. So I've just made a change here anyway. And once I make a change, you will see this little icon says 1. And that's the source control that's in Azure Data Studio. Now, for those who haven't used Azure Data Studio before, by the way, you can think of it as an alternative to SQL Server Management Studio. It supports a few different features from Management Studio, and it's multi-platform as well. So you can actually use this on macOS and Linux. Anyway, I need to commit the change that I've made, and basically this hardens the change in my local copy of the repository. And I'm just going to hit sync, and that will synchronize my local copy of the repository with what is in Azure DevOps. So if I click on here, for example, and refresh, you'll see, yeah, I made a change just now. But more significantly, if we go back here now, you will see that change has actually started the pipeline running. And this is how you will more than likely use continuous integration as part of your CI/CD strategy in the real world. So basically, once this is completed, it will have deployed an update to an Azure SQL database I have in Azure. So the other thing to note, and I think I missed it just now, so I do just want to highlight that as well. In reality, you can actually use the same task if you really want to. However, we've used a slightly different task here called SQL Azure. Well, it's for Azure, basically for Azure SQL deployments. So there are 2 slightly different tasks that are available to deploy the Azure SQL databases. And obviously the one that's got Azure in it is probably the one you should use. So that's a nice short one there. And I should probably go show these on the screen. Now we're going to cover multiple SQL instances. So we have kind of put you in the comfort zone to a degree up until now. However, we are now going to be dealing with some other concepts. So I will actually run this first. so that we can, because this actually uses Sander's repository as well. As I explained earlier, if we'd had them all to run for every update, they would all run at the same time. So let's set this to run. We'll just scroll down before we look at the YAML to see that I'm fairly ambitious of this one. As you can see, we're deploying to multiple SQL instances in multiple stages. So we're going to be doing unit tests first. After the DAP pack build, we're going to do unit tests. The unit test works, then it's going to deploy the same DAP pack to an integration environment, which is where you tend to do your integration tests. So if you have a database that works with other applications, that's where you tend to test it works with the other applications using automated tests. Then you have staging, which is also known as UAT environment, user acceptance tests, and that's where you tend to do those tests there, and that's basically the manual tests. And then, of course, lastly, we're going to, if all is well, we will deploy to production. So if I just go to another tab to make the viewing easier for everybody, and let's look at the syntax for this. So as you can see, there's a few new variables at the start. And there's the trigger again, and the triggers are quite important, obviously. Whether you can use include, you can use exclude, you can use wildcards. If you look at the YAML schema reference online, you'll see there's all kinds of variety of wildcards and references to Git branches that you can use here. We then specify we're using the local port again, because these are all, again, local containers running on my laptop. And then we scroll on down to the stage, and this is the same as earlier. So this build stage literally builds a DAP pack. However, the difference this time, whereas before it built one DAP pack from a project, we're now building from two projects. So the initial database project, which you can see here, if we go over to Azure repos and we get it to select here. So it's building the database project that's inside this folder. And this time around, it's also building the database project in this folder, which contains the unit tests. Now, before we go any further, because I'm sure some of you are probably wondering how to create these unit tests for your database. Again, Sander has written a tool to help with the creation of unit tests. So before we go any further, Sander, do you want to just demo your?
Yes, shall we? So I'm gonna share my screen. So the first thing I'm gonna do is I'm going to import my database into that project that I created earlier. So I'm going to select my database. I just want to have the object in here, and then it's going to import all the objects. The reason you want to do that in this particular situation is because all the objects have to be in the data project, because it's being referenced in the tests project. So you don't have to do the import twice, because that is all being referenced. With that, I'm kind of specific on doing rollouts for databases. I want to be sure that everything works and that all the objects are there and that somebody didn't make some kind of coding mistake. So I want to create tests for object existence. Does my store procedure have the correct parameters? Does my table have the correct columns? Does the column have the correct data type? Do I have all the indexes, etc., etc., etc.? And so I wrote a tool called the PST-SQLT test generator, which is available in the PowerShell gallery. And what it will do is it will look at your current database and then extract all the objects and then create all the unit tests based on the object type, and then output them as tsqlt. So if I run that, and the most important command, by the way, is this one, invoke pstg test generator. So let's run that little script. And you'll see that it will connect to my database and then export all the tests that I need. By the way, you only do this once because if you do this multiple times, the tests will always be successful. So just use this once when your project starts, and then use the examples to create tests if you add new objects or as anything changes. So let's add the tests that are already in there, and I'm going to the unit testing tests. Of course, because this is my demo, it's exported to the correct folder. Let's add these and let's look at one or two of these tests. So this is to test if a store procedure exists. So it does that for every single object that is in the database. And this is one of, I'll enlarge this a bit. So this is one of the asserts that are available in T-SQL-T. And the fact that I'm using T-SQL-T is, as you can see, it's just T-SQL. I don't have to learn another language like C# or maybe PowerShell when you have to use Pester or anything like that. So I can just use T-SQL. And this is one that asserts if an object exists. Well, let's look if we have another one. This is for the table. So this is another kind of test that it does. With unit testing, you usually set what the actual values are and what the expected values are. So here I'm inserting all the values that are based on the table, so all the columns with all the data types. And then I'm going to select all the columns in a similar way to get the same kind of information, and then it does an assert equals. So these are two tables being filled, and it looks at if the table is the same. So this is a really basic unit testing, but this helps you get started and making sure that a developer doesn't accidentally deletes an object and then you expect it to be there. So that is how fast you can do this. And you can see that it did this in a couple seconds. So if you have like a couple hundred objects, it could easily generate a couple thousand tests for you. So that is what I wanted to show you. By the way, this is all in source control. So
yeah, and I'm just going to take back the screen. So in case anyone's wondering, here is actually where the code, all those unit tests end up. Anyway, back to the pipeline. So it then builds the DAT pack based on that database project, which has got all those unit tests in, so that it can be deployed separately. So if we scroll down, we copy down all the files to a staging directory, especially for artifacts, and then we publish all those both those DAT packs together as part of an artifact. Then we go down through, and you can see we can actually start to deploy unit tests. And straight away, you may realize that we've got a depends on here. And for those of you who've worked with ARM templates in the past, this may be a bit familiar. Now you can use the depends on syntax and stages so that you get the order of the stage running correct if you want to. So you can enforce it here. And then you may realize there's another slightly different syntax here called deployment. It's got hyphen deployment. And that's to represent the fact that this job is actually what's known as a deployment job. And the reason that you would use a deployment job is for a couple of variables down called environment. Now, if you are working with production data that needs approvals, you will want to work with environments within Azure DevOps. Now, I know some people tend to have multiple copies of repositories and pipelines to try and organize deploying across the different environments. However, with environments, it means you can just use one pipeline and you can just use different environments for different things. So I can actually show you this now to give it a bit more context. So here you can see I've created some environments, and I've got one here called production and for example, one called unit testing. If I click on the unit testing one, you can see all the times that that deployment job has actually run in a pipeline. And I click on approvals and checks, you can see I've actually put in approval for branch control as well, which means it will only run if there's updates to a certain branch. And in this case, I've set up for the main branch. Now, as you saw earlier, various different environments I've configured. Here's one for production. And this is one which I want to show you or to highlight why this one is quite very useful to do, and it's quite important. The naming doesn't matter, obviously. I've used production name here. It can be in whatever the name of your production environments are. And here, if I click on approvals and checks, you can see that I've set up an approval, and that basically means that, an approval has to take place before that stage, that deployment job runs. And here you can see I've added myself and Sander at the moment. There's some interesting advanced options, but as you can see, that is done. And how does that work in terms of the deployment pipeline? Well, if we go back to the running pipeline now, you can see it needs an approval. So I'm just going to click on the review now and click on here and just click on approve, and that approval takes place. So this is where environments can come in handy, and you can also add other approvals and checks here as well. Quite a few different ones that you can experiment with. For example, some people use the Azure Monitor one. So what they do, if you do a deployment to SQL Server, say in a staging or an integration environment, and the performance drops for your SQL Server instance, it won't deploy the change to the next stage. So, and this has come a long way, by the way. Environments used to be quite basic in Azure DevOps. It's now matured quite a lot and it's very useful. The next thing we need to cover as well is variables, because as you can see, again, we've got another one here, new piece of syntax -group. And what that actually does is specify a variable group. And as you can see, it doesn't say variable groups anywhere. However, it does say library. So, a bit confusing, I know, but variable groups are actually stored inside the library. And again, I have multiple ones here. And for example, let's not click on the production one. Let's click on, say, unit testing. As you can see here, I've set some variables at the bottom. However, what you can do instead of adding variables manually is actually link it to key vault as well. We're not doing this as part of this session just purely because of the conserve Azure resources, because we have got some demos based on Azure Synapse, which costs a little bit of money. But what you can do is create your secrets in key vault, link it to here, and then in your pipeline, you just reference your secrets as if they're regular variables. And that will make it even more secure. Anyway, back to this. And if we go down through, all this is just separate stages deploying to separate SQL Server databases. Like you saw in the standalone SQL deployment job, this is just the same syntax in 3 different stages. So I won't need to go for anything else here. So yeah. And that is for multiple SQL instances. Now, next is ring-based deployments. And some of you may be wondering what ring-based deployments are. And it's actually quite a popular strategy that's currently being used at the moment. So for example, if we go back to the last pipeline, in fact, what I can actually do instead to make it make more sense, I can actually start this particular pipeline to run, and then I can go through and explain what's happening. So I'm just going to run on there. It goes there. And the good thing about Azure DevOps is that obviously you can open things in new tabs, etc. So say, for example, you've got a production environment and you haven't got just one SQL Server instance to deploy to in your production environment, but many. And I don't mind like 3 or 4. It could be, of course, 50, 100, or even thousands of SQL Server databases. And the thing is, with all those tasks that you see in Azure DevOps, they're only set ready to deploy to one SQL Server database at a time. Do you really want to copy and paste 50, 100 times for every stage? And of course, we all know the answer is probably no. So you might want to think of an alternative to deploy to multiple SQL servers at once. And one of the many methods that you can use was actually done by Sander earlier. So, Sander, do you want to just bring up the pipeline so you can go through your PowerShell, or would you rather I brought up?
I'll share that. So for the ring-based deployments, I thought because we have connections to all the SQL servers, and in this case, all the passwords for that particular account were the same, we could just simply iterate through the servers and deploy the DAG packs that we needed. Of course, this is a really simple solution. There are more, you could probably get more sophisticated with it when you have a different credentials, for instance. And we just listed up the servers here in the instances. This could be a list that is in one of the environment variables that we can set, like Kevin just showed, maybe a variable group or of some sort, but this is one way to do it. So we have all the instances in an array, and we have the SQL Server name and the password as environment variables, and the password is in a protected one that where the password isn't visible. We have to create a secure string because otherwise the credential in PowerShell doesn't work. Then we create the credential object, and because all the we're going to split, this is called parameter splitting in PowerShell. We're going to create a parameter object. The instance is going to be null because we're going to fill this in the for loop with the name of the instance. We're going to set the credential, the name of the database, and this is one of the environment variables that we set on the top of this pipeline, the database data, the DAG file, and the publish file, which contains all the settings how we want to publish the database. It could contain settings like don't overwrite any objects or drop all the objects that are not in the project file. Those kind of things are in the publish configuration. And then it's simply a for loop through all the instances with a little debugging which instance it's going to deploy to. We're going to set the instance, and then we're going to use the publish DBA DAG package command, which is a command in DBA tools, which is really handy to do these kind of deployments. Of course, we could do something else, like in PowerShell 7, for instance, we have for each object, which allows us to go parallel. So this would be sequential, but we could go parallel as well if we wanted to. Of course, logging would be a little bit more difficult at that point, but that is all a possibility. And this will just publish the DAG pack to all the instances, and this could be like 1, 2, or 1,000 instances, whatever you want. So yeah, that is how we could do ring-based deployments at a very basic level.
That sounds good. And in fact, what I can do, if I take the screen again. So just to show that it works, we have a group of servers here, which were all part of that PowerShell script that you just saw. You see here that the prod database that was deployed is deployed on all 3 instances. So I can scroll down here, and then you can see that it's all there, exactly the same. So it's quite useful, especially if you have one database that you need to be deployed to many SQL Server instances. Anyway, moving forwards from here, let's go to the fifth example now, which is to deploy the multiple SQL Server database types. And this may look familiar to people who attended a recent session of ours elsewhere, because it's the same logic. So again, it's a similar structure. It's based on the pipeline that you saw just now. The difference is that now that, for instance, there are business scenarios where you have the business wants you the same database project to be deployed to both SQL Server, whether that's on premises or in a virtual machine in the cloud, and to Azure SQL Database. And some people are now actually looking to do it for dedicated SQL pools in Azure Synapse Analytics as well, because they've come to realize that they can then do unit tests on a regular SQL Server database, which then gets transformed to be ready as a dedicated SQL pool. So if we scroll down to the unit test stage, this is just a regular run. And what I'm going to do, I'm just going to run this again a minute before I get too far ahead here. So it's then running the pipeline again, and I'm just going to open this up in another tab. So I will show you visually first before we dive into the YAML code. Because when you do the stages, like I said, you get these views. So as well as the regular deployments we've just done, we're now actually going to be deploying to an Azure SQL database and an Azure Synapse dedicated SQL pool using exactly the same database project as you saw earlier. So this database project here, which saves you having to have multiple copies of this project for the three different types of SQL Server related databases. Now, by default, when you go to deploy to these, let's go back down through here. When you go to deploy to these, you have to have a separate a separate database project. That's got a different target platform. However, there is a way in Azure DevOps that you can actually change the target platform behind the scenes by making a separate copy of the repository somewhere secure on the agent and then converting it. And I am going to show you that now. So let's go scroll down a minute to the actual correct part. So here you go. So basically, and I'll make it a bit bigger to make it a bit more visible for everybody. So what you do, you actually get that database project and you copy it to a secure area. And then on your secure copy, you run a piece of inline PowerShell in Azure DevOps, which changes one line in the SQL Podge file, which says basically change it from a SQL Server 2017 project, as you can see here, to one that's for Azure SQL Database. And then you just rename the file just so that you get a different, that pack created with a different name, which makes it easier to recognize. And then you just build and publish. And then the deployment is the same deployment we've done before. Only difference is I'm using a Microsoft hosted pool this time because it's in Azure. And then it's just a regular deployment to an Azure SQL database. And if we scroll down here, it's exactly the same idea for Azure Synapse, except instead of changing it for obviously an Azure SQL database, we change it to the data warehouse schema provider. So if you are looking to change the target platform to be used for Azure Synapse Analytics dedicated SQL pool, you will have to use the Azure SQL data warehouse target. And the only other thing that's different here when you go to do the deployment using the task is that the server name is actually the dedicated SQL endpoint you get for Azure Synapse Analytics. And just to show that these pools actually exist, let's go to here. And you can see here, this is Azure Synapse Analytics, and this is Synapse Studio. So if I navigate through here, and it opens up, you can see it's exactly the same database that we've been deploying to everywhere else. So that is how you can do unit testing for an Azure Synapse Analytics dedicated SQL pool. And as well, that's how you can convert to multiple types without having a major headache. Now, there is another way you can do this as well. You can set your SQL project just to ignore any errors. However, yeah, you could have some unexpected errors appear and obviously not be aware of it if you use that method. So it's entirely up to you. This is just one way to do it. And also demonstrates that with a bit of imagination, you can do a lot of things behind the scenes with the YAML code as you get more used to the schema, because you can do more other things like conditions. You can do nested pipelines as well. As you can see, this pipeline is quite long and it's just purely for demonstration purposes today. I can actually split it up into multiple YAML pipeline files, which are then nested and then called within each other, just for ease of admin. And it also can potentially help with some performance issues at times as well. So it's just to make you aware of that. And last but not least, number 6 is to transform an Azure Synapse dedicated SQL pool. Now, what I mean by transform is just basically, if we go to the repository for it here, you can click on the down and click on, hopefully this is the right one here. Yep. So say, for example, you have a database project and you have various, say, for example, here, you've got a table that's been created but hasn't got a distribution strategy. What you can do, for those who aren't aware, there's 3 distribution strategies when you create a table in Azure Synapse Analytics dedicated SQL pools, which are round robin, replicated, and hash. And hash is used for the very large fact tables. Replicated is very useful if it's a very small table and it's a small going to be a small dimension table, for example. Then you can set it to replicated, and what that does behind the scenes in Azure Synapse will put a copy of that table, the full copy of that table on all the nodes behind the scenes that I use when it's doing its parallel processing. So it's quite useful. So if you want to change the distribution type here, all you have to do is go down here, go to 6. If you click on edit here, and it's very similar to what you saw just now conceptually. We're making a copy and then changing using PowerShell. So all you do, yeah, you can just use the PowerShell to manipulate the actual SQL scripts inside your database project. So here you can see you can change it so the distribution is replicate, and that will just change it for that particular file that I've referenced. So when it gets up, when the DAT pack is created, it's created with that new distribution in there instead of the default. And with that being said, there are a lot of other things as well. I recommend looking at the YAML schema and getting used to all the other features. You can put conditions in, etc. as well. Obviously, within 60 minutes, there's a lot we could show, and there's still a lot more. But I hope this has made some of you more comfortable with using YAML for your deployments. Now we are.
Yeah, I think we're almost out of time. So I wonder if anybody has any questions.
Yeah, I think there's 15 minutes for questions. So what I can do is show our contact details again.
And I'm checking that right now for the questions while you do that.
And what I'm just going to quickly do, I will bring our contact details back, but obviously special thanks to Microsoft as well for their support for today's event. You also need to remind everybody that there's ways to win prizes as well. So yeah, post a selfie with yourself in front of your workstation. I understand that that's become a very, very popular these days. So yeah, take a selfie of yourself with that hashtag. And look to win a prize if you want to. And like I said, here's our contact details again, and some of the things you've seen today are available on either of our GitHub, basically. So you can find us, follow us,
All right, so
go from there.
there seems to be just one comment or question there. Yes, so this is from Raghavendra. Okay, he's asking for, can you share the code for the demo?
Yeah, so some of the code for the YAML templates are already available, either in mine or in Sander's GitHub already. Like I said at the start of this session, we do intend as well, because part of today's T-SQL T, that we are actually, well, I'm going to be uploading some more of the YAML that's similar to what you've seen today, later today. So if you follow me on GitHub, or if you look on my GitHub later today, I think it's being published around 3 or 4 o'clock. I have to double check what time that is now. And yeah, so at 3 or 4 o'clock, the repository will be available public as well, with the
Sure.
code in there.
Even there's another question. Katie has a question: how to manage dynamic number of variables in YAML?
Dynamic number of variables. There are multiple ways you can do that.
And the follow-up comment, sorry, Kevin, and the follow-up comment was, few do not exist in UAT or prod.
So can you repeat the question again? How to control the dynamic number of variables?
How to manage dynamic number of variables in YAML? And a follow-up comment came from Kerry, which says, few do not exist in UAT or prod.
If you do not exist in UAT or prod? Or
No, few, F-E-W, few.
Ah, can you put it in the chat as well? Because I've got the chat open at the moment. So
okay. Yes, I'm putting up in the chat for you. Maybe you could just proceed by this question, and then we'll check with Kerry if that is good enough, the answer.
Yeah. Dynamic number of variables in YAML. Katie, can you give us a bit more context about that, just so we can, because obviously you have the variables in the library that you can use, but I'm guessing you mean other dynamic variables. So if you can give us a better idea, then we'll be able to answer for you.
Okay. Kevin, there's one more question from Srinivas. Let's take this one up. I've put it up in the chat window. We have challenges differentiating pipelines for environments in YAML. We have 3 different YAML files, one for each environment. Is there a simple way to implement this?
Yes, and I did cover this earlier in the session. Let's go back to it now. So, and it's actually still open. You can use this. Hopefully my screen is better visible here. You can use environments now in Azure DevOps, and I do understand that when a lot of people went to use environments in Azure DevOps last year, it was a bit limited in what you can do, but it has matured quite a lot. So you can use your environments here. You can create your own environment from scratch, and as I showed earlier, each environment, you can put your own settings in. You can put in your approval and checks process here, the security for it. So that is how you set the different environments there for approval purposes. And then what you would do is, like I showed earlier as well with the deployment jobs, is that you would actually as well have a different variable group library for each environment as well. So as you can see here, let's click on integration. So you would have the different variables depending on which variable group they used. So you'd put your different server names, etc., in these variables, in the variable groups in the library. So my recommendation is to use your environment and library features together to do this. Your environment mostly for your approval process, and your library to manage your variable group to put all your variables in, which will change from environment to environment. I hope that answers the question for you. Just thank you very much, everybody involved with this session, including obviously the organisers, attendees, sponsors, etc. And
thanks for attending.
Thank you very much. Thanks, guys. Thank you, Kevin Stander, for coming on board again this year and sharing your expertise with the audience.